So Hildebrand's a kind of multifaceted company, and I'm going to zoom in on one aspect today of interest, I think, to this audience, which is about how we're supporting innovators. We do a lot of work with the supply side business, but come find me afterwards if you'd like to know more about that. So this is a diagram that's kind of shown in official documents. So this came from the National Audit Office report on justifying why smart meter investment is good for the UK. And in our opinion, it misses a few really key aspects of how a consumer can get engaged with their energy use. You've got in-home displays, and you've got metering technologies, and then you have this mystical green line that comes from the top, which is the internet that somehow lands on a computer. And really what Hildebrand's all about is putting a CAD in the mix, or a consumer access device, and luckily that's been explained at least 3 times, so you should kind of understand what consumer access device means. And that becomes actually something that's in the home that can do some things locally, but also then reaches out to the internet to either provide data or, and sometimes get control signals back to affect things in the home. We've also learned that CAD devices are sort of complex and require special access and special privileges. Not just anyone can go out and purchase or make one of these and put it into the energy infrastructure. So the second diagram, which is of interest, is all the back office that goes along with the UK smart metering. And if you look at the DCC in particular, that encompasses the 3 roles that we were just talking about. And many people in this audience probably said, hey, I would like to become another user. That sounds pretty interesting. I'd like to be able to get data. I'd like to be able to put CADs in. And each time it's sort of like, well, yeah, if you're a one-man band, it's not going to happen, or it's going to be very, very costly. And what we're offering on this side is the ability to support people in that way, to become a proxy, I think was used in another talk of Simon's, to make sure that all of that secure infrastructure is still secure, but also puts innovators right in the mix so that you can actually get stuff done. I'm going to go back to this slide for just a second and also mention that there has been some talk. I think I saw one slide and it had, and even somebody said a hairdryer, could be potentially and technically that's true, of course. You could put a hairdryer onto the smart meter infrastructure. But it kind of appears that in the experience, since we've gone through this with SMETS 1 and SMETS 2 now, and Hildebrand's been involved in these rollouts all over the world in different places, there are very few devices that actually get hooked up to the smart metering infrastructure. They're the possibly very big important ones, like electric vehicles. I can imagine that will be something that will be controlled by the smart grid. But in essence, if you have a stove or an oven or a refrigerator, it's most likely it's going to integrate through the internet. And there are going to be a wide variety of ecosystems which are going to support that, from manufacturers like Samsung, Apple, etc., Google. So what are we aiming towards here? And really, we've got energy suppliers are, our bread and butter. An energy supplier is very critical to our existence. We are helping them, and I think Octopus is a good example, and I'll show another example of one of our customers, of innovating. What does an actual energy supplier do? Are they really, just buying and selling energy, or are they helping people in the way that they consume and the way they change their behavior, and the products that they can actually use to do that? Developers, I think we're at such an early stage of all the potential of this that it's our intention to help developers get products to market. There will be probably 60 or 70 energy companies in the UK for the foreseeable future, and each of those, you don't really want to go and knock on each of their doors to ask permission to be able to sell products, nor do you want to have to go through all the technical interoperability testing that has to happen. What we're trying to do is say, well, you can sit as a developer, you can sit above all of that technical detail and use us as a partner and an infrastructure to deliver into that. Partners, This is people like Landis and Gear, who spoke earlier, people who are making electric vehicles. These are partnerships that we've got in order to expose APIs and to do the heavy testing underneath. And we're always looking for partners. People are innovating all the time in that area, and I think we'll see some new and exciting stuff coming out in the future. And the fourth area is researchers. We still don't know everything about the way the energy systems are going to roll out in the next 20 years, or even the next 2 years for that matter. So we're going to have all this pool of data. We already have this pool of data. How do we get that to researchers who can actually tell us what's important and where we should be focusing our time and effort? So we've talked a lot about CADs. I don't think anyone's actually shown one. So voila, this is a CAD. It's also an in-home display. It has a Wi-Fi chip that basically bridges the data that's being harvested from the smart meter and being displayed. You may already have a display in your home today if you have a smart meter. Some people refer to this as the smart meter, which is shocking but true. And the CAD is basically just taking that data, and consumer has complete control over that. They can turn off that access with the device, shooting that up to the internet, to our services. So what do when we say CAD data, we've alluded to a few things, and I just want to point out some of the interesting areas. So there are quite a few meter technical details that get sent to us. And on the DCC, these are available, but sometimes if you don't have a DCC connection, or if you're trying to, I don't know, work in a SMETS 1 environment, you may not have access to all these meter technical details. And they're very, very handy for a number of reasons, especially for energy suppliers who are rolling out smart meters. The second area, the real-time area, where we have power, and there are other real-time components, so voltage and phase and quality indicators and things like that. And those haven't been exploited at all in applications yet. That's why they're italicized. We're getting that data. It's the only source of that data. So DCC, for instance, just holds that half-hourly profile. We know that gas is not very real-time, but you do have that half-hourly data, which is going to come to you as the half hour closes off. So for instance, in the DCC world, you might have to wait till the next day in order to actually go and get all the half-hourly profiles down. Now, it's not to say that you couldn't just keep requesting the half hour, but DCC are probably not going to be very happy if we start to flood their network with tons of half-hourly requests for gas data. The profile, some people know this in the room, some people might not, but there are 13 months of history on meters, both gas and electricity. So if someone has a smart meter today, even though it might not have a hand connection or may not be using the data in any way, by putting a CAD on, you actually can go back and get 13 months of history, or as long as the meter's been installed, which is quite interesting when you're trying to start up an analytic application and you want to get nice history. You can actually do that right out of the box for some customers. And as Phil was alluding to about pricing and time of use, the meters themselves hold the prices. So the local infrastructure, the CAD itself, is aware of what the current price is and knows when that schedule of pricing is going to change. And therefore, you can inform, say, the washer and dryer, the electric vehicle, et cetera, based on price. Prepayment events are also facilitated very much from the sort of local pricing clusters. So you can move a meter from credit to prepay. There's no physical difference, so it's just a change in the head end. I know people sometimes ask, do I need a new meter if I go to prepay? And those capabilities are just a software change. And then you've got things like events. So events are something that are getting more and more enhanced, and I haven't listed all of them out here, but there is an ability to send a message to a smart meter, and a lot of times if there's a service disruption or there's an outage, then sometimes those types of messages will get sent to a meter, and the CAD gets those and can act on those and send those back through to the internet. Alarms and price changes are there as well. So how do we turn that into a service platform as Glow? And we use the name Glow to just sort of encompass all of the hardware and software and services that go around delivering this type of thing. So we have user areas where we're doing things like pre-clustering users based on their consumption types. This allows you to use benchmarks and other models, pick from a library of models that will work for that cluster group. So if you know it's a stay-at-home retired couple, they're going to have very different usage patterns, and they're going to have very different needs than someone who's a busy working family. Verification process. So in our apps, we have a verification process, and we use some of the meter technical details to work outside of the supplier to be able to verify the end user. This is an enormous problem, and will become more of an enormous problem as people start saying, well, the technical details have been done. I've got a CAD. I can actually wire it up. Now, how do I not need a call center to be able to validate and use Experian, credit reports to validate whether a consumer is who they say they are? So we're running a verification process service on behalf of others. And we have a supplier network. So a lot of suppliers are looking for innovation. They don't have large teams of people doing development, so they're very happy to take new innovation and drop it into their product portfolio, and we facilitate that. Data, we're not exclusively working with SMETS 2 data. We're working with SMETS 1 data across the Secure Meters network and CGI. Also, we take in AMR data, especially in the non-domestic sector. There's lots of AMR data that will remain. And then manual reads. Oftentimes people forget that sometimes manual reads are still the way that data gets put in, but you can do things with that manual read. I'm just going to highlight a couple of more, and then you can probably read the rest. But we preload weather data, EPCs, OpenStreetMaps, food standards, for instance. And then we have some analytics. Some of them have been created here at Salford. So the HTC calculations are being done here so that we have a real-time heat transfer coefficient, which is about the thermal loss of a building. And that's directly measured rather than reported through some sort of audit. There's ongoing work there to improve that model, and there's a number of researchers in the room here that are working hard on that. Usual things you'd like to see in analytics, and I'll go through that more. And then we have software developer kit, a software developer's kit, which includes support for a number of languages, as well as just straight RESTful APIs if you want to use those. And then we publish the event streams on MQTT. If you don't know what it is, ask your neighbor, they'll tell you. Operating highlights, we've got people using our systems in about 27 different countries. We have 50,000 devices. I think we've collected over 500 billion real-time data points so far. So we have a large set of data that we're able to run analytics on and use those models to help inform your models, et cetera. The tariff engine, inside our meter data repository, so all this data coming in. Remember, DCC doesn't actually store your data for you. The data is coming from the meter. And when you start to request this data, it ends up being I would like to say a different word, but a shed load of data. It is very difficult to deal with. And if you want to actually then turn that into pounds and pence, you have to do that yourself. And with time of use tariffs and other complex pricing mechanisms like incline block, et cetera, that's a very complicated thing to do. And our tariff engine automatically turns things into pounds and pence. We also support push notifications, and that's important for triggering the behavior change that Phil was talking about in terms of plunge pricing. And then if you look at analytics, some of these are still early days models. We're kind of doing them as proof of concepts, but being able to look at refrigeration loads, it's reasonably easy. EV charging is reasonably easy. Lighting loads in commercial space are reasonably easy. Occupancy and operational hours, you can determine that through electricity patterns. And we're working a lot with GPU type stuff. So we're building up a lot of GPU instances to be able to do these calculations in real time on very large data sets. I'm going to go through some of our applications in a minute, but these are often, we give these out to our energy suppliers, customers, as starters, so they don't have to actually reinvent the wheel in terms of an application from day one. It's a little description. I mean, this is quite a basic diagram, but the idea is that our partners who are developing applications and analytics go into the Glow Mark or the marketplace for our apps. Application developers can either build on top of those analytics and develop their own applications, or dive into the deeper bowels of what we do in terms of device management or the engine, the data engine itself. So if you have any interest in becoming a developer, I'm just going to give you a quick peek, but please come find me afterwards. I've got even a free gift if you sign up to be a developer. You'll get a set of credentials which allow you to then create your own apps. I'm using one of our examples, so Eversmart Energy, which I think is Manchester's only energy supplier, and I'm one of the best in the UK, of course. This is sort of their instance of the application developer portal. So they're given a set of app keys, and they can create mini app keys based on whether it might be an app for a niche, or maybe it's their main application to support their user base. Then they're given a set of, and this is all quite cryptic, but this is for developers, and we're going to soon build from this. They're given a set of sensors that they can tap into. Some of them you'll notice are smart meters, and some of them are things like temperature sensors. So it takes into consideration managing an entire IoT space, not just the smart meter space. However, the smart meter space is very easy to get to grips with very quickly. Then we have things like various language content. So working in different countries, we've got to be able to support multilingual applications. And you might even do that for different customer segments. So you may customize alerts based on what that customer segment looks like. The alerts can be templated here, so the push notifications, and then those can be triggered through threshold settings, or external customer services can push a button and send push notifications out. So if a pricing change results in a plunge, then that can be set up as an automatic trigger. For those of you interested, all of our documentation is in Swagger, and the SDKs are what you would expect in terms of Python, Node, PHP, etc. So I kind of went through and thought, all right, when you talk about data, what are you intending to do? When you're innovating with data, what is it that you really want to be doing with data? And I'm not an academic, so this is not an exhaustive list. But in general, you see there's something that you want to use to communicate visually to people. So you're trying to, I don't know, maybe show or highlight some alert or anomaly that's oftentimes in monitoring. Sometimes you want to just be able to explore, so there's an interactivity with the data. That requires the ability to move through different time, so being able to slide back and forth through time, being able to drill down. So you may see, in some of Phil's diagrams, he was showing some hours where there were peak, but you may want to actually start drilling down into that and start to say, how can I start to explain what's going on within that hour? How can I start to look at more detailed data? I'm going to show you some examples of that. Analysis, so you might want to actually set up models and measurements. These are becoming more and more sophisticated. We'll do an example of a pretty sophisticated one of those. Maybe purely commercial, so I know someone mentioned about actually doing a peer-to-peer trading or some sort of blockchain. This is where the data actually is the product. So it's important to be able to support those use cases. And then sometimes we want to be able to control this. So it could be that the data is actually just a signal. So in the type of an analytic world that we work in, we host Jupyter Notebooks for our developers. So developers can come in and use our instances. They can put their application keys. Those are shortened, so don't copy them down and think they'll work. And then you can just instantiate these sort of glow objects and begin to put time ranges in and drill down. And that delivers the data to the Python environment. And then the next thing you want to do is run a model, let's say. So for instance, we've got an LSTM, or long short-term memory neural network model, which we use for some predictions. We don't use it for all. But you can basically train a model on different granularities of data. This one's done on an hourly-based data, but you could do it down to the minute level. You remember the granularity that a CAD's going to give you is right down to the minute. So if you think that informs the model, then you can actually take the time to compute and have your predictors working at that kind of granularity if you wish. This example was one that we've turned in, so Alex Marshall and a few of the guys here who are working on Endosemic. This is actually one of the businesses that's in the project. And with an LSTM model, we got a really good fit for being able to predict an hour ahead on an LSTM model. This just shows the fit, if you can see it. Kind of exploration or sense checking data. This is kind of a heat map technique, but again, really easy once you have the data. And you can do this. This is on, I think, about 200 businesses, so also in our non-domestic work. We can start to see, and there's probably a laser pointer in here if I knew how to work it, but you can see that there's kind of a gap in the right. And that just shows that there's something interesting going on in terms of operating hours. So it informs the next question. It probably doesn't give an answer, but it informs the next question of where should we look next to have that impact or look for answers. And then talking about applications. So once we move out of the analytic world and you've got models that you want to use, so in terms of forecasters, a lot of times we use that with our energy suppliers, so like Eversmart, for instance, to be able to help consumers set goals that are reasonable for themselves. They're reasonable for them to meet. So it's a customized model for that household. It's not taking literature review or benchmarks and trying to apply that to the wide population. It's saying, we've got 13 months of history for you. We know what you're doing. If you would like to start to save 20%, we'll actually make a forecaster which will help us do that and track. So with Eversmart, we've launched a fairly simple, what we call sort of in-home display on the go. So I can look at what my house is doing anywhere I am in the world. I can see the real-time power, which is at the top. I can look at what that's costing me by day, week, month, etc. And you can flip units, which is quite easy. That might look like a trivial little flip, but when you're on a time of use tariff, that becomes quite non-trivial. Menu's not that interesting to look at. And then you can start breaking down the kind of usage patterns. So this is electricity, and I can get right down to minute level. So you can really see those patterns of cooking emerge. So this is a typical, I don't think this is my house, but it's a typical house. In the evening time, this is probably a weekend, no, it's a Wednesday, so you can see there's sort of cooking going on in the evening. Overnight, you can see what the base load is. You can see that oscillating refrigeration happening. Just by even looking at this data and starting to immerse yourself in this data, you can start to look at opportunities for businesses and change and new devices that might help manage that situation. Likewise, we can do that for gas, but we can only go down to a half hour, of course. And then we can kind of start to build on that, and sharing data at a household level, I think will at some point, I know there's a lot of concern about security and other things, but sharing of household data for the better good of a community or a neighborhood or a family is probably something we'll see very, very quickly once this SMETS 2 world becomes the norm. Where it's actually happening quite rapidly is in business, because businesses don't have the expertise to analyze their own data, and they don't have the expertise to necessarily share those reports and interpret reports. So they want to distill that data into easy-to-use applications for business employees of the business. So with Salford, who's doing the building physics work, we're working on what we call a middle-out approach. So this is not Silicon Valley middle out, if you watch that show, but it's looking at the, instead of being the producer and the direct consumer, we're looking at the people who influence. So we're all occupants of this room, and we're using a lot of energy in here, but we're not really the bill payer, and we're not the producer, but we're in the middle, and we're influencing. We're the guys who decide whether we turn all the lights on or turn all the lights off. So we're doing that through a few applications. One's called Assure, and this is where we're integrating things like OpenStreetMaps and building level data to be able to benchmark and hook smart metering data up so that business can then set budgets and be able to track those and kind of look at I guess exceptions and put projects in. So if they have capital expenditure they want to put forward, so it might be LED light bulb upgrades, they can look at what that's going to yield in terms of impact. I think I've talked mostly about what our Smart Engine does, so just a little bit of a reminder there. And really what we're doing is inviting, if you kind of fall into any of these categories, we're very receptive to trying to create some sort of support for you within Hildebrand, and we'd be very happy to have you involved. So probably questions for about 2 minutes if you've got them yet.
Okay, so thanks very much, Josh. That's so we've got time for a couple of questions before we go to coffee. Any questions for Josh?
Josh, it's Nigel Wally from Chimney. We're building home dashboards for homeowners, and one of the data sets we're looking to control is the utility stuff. I had a question about ownership. Whose data is this?
The users, the occupants.
Okay.
It's not even the building owners, it's the occupant of the building. They are the one who own the data. They're the data subject.
That's an interesting question. So if I buy a house that's had one of these meters in for the last 13 months, I can't request back that. I can't say, show me what it's cost to, or...
You're not allowed at this point in time, you're not allowed to see that history if you were not the occupier of the premises.
Thank you.